Hello everyone. The problem that we're looking at today is the USACO 2021 January contest Gold problem 2 of telephone. And I actually really like this problem because there are two ways actually to solve this. One using dijkstra's algorithm and second one using a layered graph shortest path algorithm. And the method that I'm going to be explaining today in this video is going to be the one using dijkstra's, and the layered graph shortest path is going to be explained tomorrow after I explain first another problem that is the more basic version of layered graph shortest path, which will help you understand better how to solve this one using layered graph shortest path. So first of all, let's take a look at how to solve this problem using the first algorithm that I'm going to be explaining today. So first of all, you can pause the video first and look at the problem yourself. All right. So basically, you have n cows again standing in a line, but this time n is only 5 times 10 to the fourth, and the ith cow has a breed, with the breed being only 50. The 50 in this problem is actually not going to be that useful, but in the next algorithm, layered graph shortest path, the 50 is really important. But in the method we're using today, it doesn't actually matter. But so we have k breeds, and a breed I and j, whether they're willing to communicate with each other, is given by a matrix. And now you're trying to determine the minimum amount of time needed to transmit the message, and for it takes I minus j time to transmit the message from cow I to cow j. And that's only if the two cows have a breed that are willing to transmit from I to j. And they're trying to determine the minimum amount of time needed to transmit the message. Now you can pause the video once again and think about this problem yourself. Alright, I assume you gave this problem a try. So the first thing that we notice for this problem, well, at least the first thing that I noticed, is actually very important. Because if we take a look, I'm just going to use different colors to indicate the different breeds, right? There's a red cow, red cow, red cow, and then we have maybe a few blue ones, and then green, right? Let's say red is willing to communicate with blue, right? So we realize that for every red cow, we only actually ever get the message from the shortest two blue cows. We never get a message from any blue cow that's not the one with the minimum distance from it on the left side or right side. Oh, sorry, I said something wrong. If blue are willing to communicate with red, not the other way around. So if blue is willing to communicate with the red, and if we know that this cow got its message from a blue cow, well, then it could have only gotten this message from this cow or this cow, the closest to this red cow right here. It'll never get a message from this cow, or if there's another even farther blue cow, those cows will never transmit the message to red for the answer to be optimal. And why is this? Well, let's take a look. So if we say transmitted the message from this cow, which is not closest, well, we realize that actually what we can do is just transfer from over here. We do that twice, right? No, not necessarily, because blue might not wanting to communicate with blue. So let's say there's another more distant point, say purple cow or something, that gave this message to this blue cow. And then from this blue cow, we go to this red cow. And we realize that actually, instead of giving it to this blue cow, we could have just given it to this blue cow and then going to the red cow. And that would not make the answer worse in any way possible. Because the cost of transmitting a message between every two cows is just the number of cows between them, plus 1, right? So transmitting from this blue cow to the red cow is going to be 2, plus obviously the cost of from the purple to this blue. But if we just go to this closer blue instead, we'll have a cost of only 1, plus an extra cost of transmitting from the purple to this blue cow, and the cost is going to be consistent with the previous method of going to this cow, right? So now we know if the cow that gave the message to this cow has a coordinate after this blue cow, well, obviously choosing this cow instead will be optimal. But what if it came before? What if we have a purple cow over here on the left side now? Well, it's still not going to be worse, because if we transmit the message over here and then back, it's actually not going to be optimal. It's going to be even worse than doing just that, right? That's actually going to be optimal. So instead of having a purple cow in front where the answer just doesn't change, this time if we switch to the closer blue cow, the answer actually gets even better. So from that, we can see that no matter where the previous message came from, we always get the message from the closest two blue cows for this red cow. And that applies for any two colors in any position. So now we know that for any cow, if we know which breed it'll get the message from, it must be from the closest to this cow of that breed. And actually knowing this allows us to run dijkstra's shortest path algorithm because we know that for every cow, there can be at most 100 edges coming out of it. Because originally there could be n squared edges in total because every cow can connect with every other cow, but in this case, there's only 50 breeds, right? And each cow can only connect 2 edges to every other breed, and there's only going to be at most 2 times 50, which is 100 edges coming out of each cow. And with a total of only n nodes, which is 5 times 10 to the fourth, we can run Dijkstra's algorithm in the correct time complexity now. However, I was not that smart during the contest because I came up with the observation of every cow only goes to every adjacent cow of the breed. I did came up with that idea during the mock contest, but instead of running Dijkstra's and connecting edges, I was so stupid that I actually just did a DP for every cow. If it was transferred from a cow of breed J, well then what is the minimum time it could have took for the message to reach I from 1. Even though this algorithm does not provide the correctness because I only iterate through 2k transfers. Oh wait, no, actually I was wrong. My DP actually means after after I transfers and reaching right now breed J, reaching right now cow J, sorry, what is the minimum time it takes? And for each time I iterate through which breed it transferred from. However, this is not the correctness or complexity actually, because I only iterated through almost 2k times of transferring, but that's actually not correct because there could be way more than 2k possible transfers. Even though at first I observed the property that each breed can only be visited once unless it's 1 and n, right? Because if you think about it, every time that you go to breed the second time, you could have just gone to that cow of the breed the first time. However, my program is based off both of these observations, but when the first one is satisfied, the second one is most likely not. So, with this being said, there could be way more than 2k transfers if you only transfer from the closest cow of this breed to I. So that's why this algorithm does not have the correct correctness or complexity. However, it still somehow receives 79% credit, which is really good. But I didn't actually implement a dijkstra's algorithm for this problem, so there's not going to be a code posted in the comments below today because I just implemented the layer graph shortest path algorithm instead of this one. So yeah, that's it for today. I hope now you know how to solve this problem. I mean, the programming is not going to be that complicated. You connect edges and run dijkstra, and it's just very basic. So if you're looking at this problem, if you're trying to work on this gold problem, I assume you already know how to do that. However, the layer graph shortest path algorithm that I'm going to be explaining tomorrow does have a code and detailed explanation along with it. So if you're interested, you can go watch that video that will be posted tomorrow. All right, thank you for watching. All right, that was the problem review of today, and now it's the ground report. So today I've been a little sick, as you might be able to tell from the voice, especially in the last video that I posted today. So I didn't actually have much time to get a lot of stuff done, even though it's a Saturday. But I did accomplish something. So first of all, to still keep my streak going of at least solving one problem every day, I solved the USACO 2016 December contest gold problem 1 of MooCast, which is really, really easy, especially since it's 2016 December. But it's a problem in accounts, so I still solved it and recorded down. And I actually did something very meaningful. I actually turned all my problems that was recorded down on paper into digital. I typed all the problems I've done since December 19th of last year all the way until today. I typed all those problems into a Google Doc, and now I'm planning on giving every problem a difficulty and assigning it how many times I should study it before February contest at least, so it can help me better review these problems. And I counted a total, not counting the one that solved today, the mood cast. There's a total of 25 problems that's between 2001, 2010, and 2020, and a total of 37. A total of wait, how many? A total of 37 problems that's between 2020 and 2025. And there's a total of 17 problems from December contest, 17 from January, 17 from February, and 11 from US Open, with one additional problem of a problem on Logu. And also plus one today. So there's a total of 64 problems, counting the one today, that I have solved since December 19th of last year. So that's pretty good, considering that there's only been pretty sure 23 days since December 19th to today, and I solved almost twice the number of problems. So basically 2 problems a day. So that's really, really good. And I actually also want to take a second and show you guys my logo history. As you can see, logo, I have the same account name as my YouTube account, but last month I was only able to solve 40. But if you look back to November, I've only solved 22, and I started grinding in December, getting 40 problems. And this month I've really locked in, kind of, not really, but I kind of locked in, and I was able to solve, I think, 37 up until only 11th of this month. So that's pretty good. And there's been even 3 days that I solved actually 5 problems. So now I think it's really good that I turned all those problems in digital, because I used to just have them down in a notebook, and that's just not very convenient. So this is very good, and now it helps me review because I can summarize the difficulty of each problem. All right, so that's it for the grind report. I didn't actually grind very long because I was kind of sick, but I still, I think, studied for 2-3 hours, just summarizing the problems and reviewing them and giving them a difficulty. But yeah, I'm kind of cooked for January, but it's all right. I'll still try. See you guys tomorrow. Thank you for watching.